Today is July 9th, 2025. Over 56 years ago, humanity took a giant leap, landing on the moon with the Apollo 11 mission. This was not just a victory of big machines and powerful rockets. It was a triumph of human skill, where many critical parts were carefully made by hand. The world watched as Neil Armstrong took his first step, but behind that moment were thousands of people on Earth. They were building the future, one stitch and one wire at a time. The technology they created had to be perfect, because in the vast emptiness of space, there is no room for mistakes or second chances. This is the story of that incredible handmade technology. The journey to the moon was fueled by the Cold War. The United States and the Soviet Union were in a great race to show their power. This space race pushed scientists and engineers to invent things that seemed impossible. They needed a rocket big enough to escape Earth's gravity, which led to the mighty Saturn V. They also needed computers that were small but powerful, something that did not exist in the 1960s. Every single piece of equipment, from the astronauts' suits to the capsule that brought them home, had to be invented from scratch. It was a time of great challenge and even greater imagination for everyone involved. This mission was a unique mix of futuristic ideas and old-fashioned craftsmanship. While powerful computers were being designed, many essential components were not made by machines. They were built by skilled workers, many of whom were women, using their hands. These weren't just simple tasks. They required immense precision and dedication. For example, the memory for the onboard computers was woven by hand, like a digital tapestry. The spacesuits that protected the astronauts from the harsh lunar environment were sewn with the care of a master tailor. This human touch was the secret ingredient that made the impossible journey to the moon a reality. The pressure to succeed was enormous. The entire world was watching, and the lives of the three astronauts, Neil Armstrong, Buzz Aldrin, and Michael Collins, depended on this technology functioning flawlessly. Every scene, every circuit, and every parachute fold was a promise of a safe return. The people who built these components knew this. They were not just doing a job. They were part of a historic mission that would change how we see our world and our place in the universe. Their careful work, often done quietly in factories and workshops, was the foundation upon which this grand adventure was built, taking us from our blue planet to the gray dust of the moon. For the Apollo 11 mission to succeed, it needed a brain. That brain was the Apollo Guidance Computer, or AGC. At a time when most computers were as large as entire rooms, the AGC was only the size of a small suitcase. This was a revolutionary achievement. There were two of these computers, one in the command module orbiting the moon, and another in the lunar module that would land on its surface. For the first time, astronauts could directly type commands into a computer using a keyboard, which was a huge step forward from the punch cards used by other computers of that era. This gave the astronauts direct control over their spacecraft. The AGC was designed and programmed by a brilliant team at the Massachusetts Institute of Technology. It was the smallest and fastest computer of its time, able to perform complex calculations for navigation and flight control. The computer had to guide the astronauts across 250,000 miles of space, help them land gently on an unknown surface, and then bring them back home safely. During the final moments of the lunar landing, the AGC famously became overloaded with data. However, it was smartly programmed to prioritize the most important tasks, allowing Armstrong to land the lunar module with just seconds of fuel remaining. The memory for this amazing computer was just as special. It was called core rope memory, and it was a marvel of engineering. To store information, wires were woven through tiny magnetic rings, called cores. If a wire passed through a core, it represented a 1. If the wire went around the core, it represented a 0. This process was incredibly detailed and was done entirely by hand. Skilled women, many of whom had previously worked in textile factories, were hired for this job. They used their expertise in weaving to literally weave the software programs into the hardware, creating a permanent and unchangeable memory system for the mission. This hand-woven memory was extremely reliable, which was crucial for the mission's safety. It could not be accidentally erased or changed by a power surge or radiation in space. The process was so difficult and required so much skill that it took 8 weeks to create the memory for just one computer. These women, known as the little old ladies by the engineers, were the true guardians of the mission's software. Their careful and perfect work ensured that the computer's instructions were locked in, making the complex journey to the moon and back possible. Their contribution was quiet but absolutely essential to the success of Apollo 11. To walk on the moon, astronauts needed a special kind of clothing. The Apollo spacesuit was much more than a simple outfit. It was a personal spaceship. Each suit was made of 21 layers of special fabric, all carefully sewn together by hand. These layers had to protect the astronaut from extreme temperatures, from burning heat in the sun to freezing cold in the shade. The suit also had to be strong enough to stop tiny, fast-moving space rocks called micrometeorites. The company that made bras and girdles, Playtex, was chosen to make these suits because they knew how to create garments that were both strong and flexible for the human body. The task of sewing the spacesuits was given to a team of highly skilled women. Every single stitch had to be perfect. A small mistake could create a weak spot, which could be disastrous in the vacuum of space. The women at the factory worked with extreme care, understanding that a life depended on their work. The result was a suit that was tough on the outside, but allowed the astronaut inside to move and work on the lunar surface. This incredible piece of handmade technology was a shield, a life support system, and a mobile home all in one, keeping the astronauts safe as they explored another world. While Apollo 11 did not have a car, later Apollo missions did. Astronauts on Apollo 15, 16, and 17 drove a lunar roving vehicle to explore more of the moon. The wheels for this rover were another amazing invention. A normal rubber tire would not work on the moon because of the extreme temperatures and the sharp lunar rocks. So engineers at Goodyear designed a special tire made of a hand-woven mesh of zinc-coated piano wire. This innovative design was flexible, allowing it to roll smoothly over the dusty surface, but it was also very strong and durable, a perfect solution for a difficult problem. Just like the spacesuits, these special lunar wheels were assembled by hand. It took 3,000 feet of piano wire to make each tire. The open mesh design of the wheel was very clever. It provided good grip on the fine lunar soil, and as the wheel flexed, any dust or dirt that got caught in it would simply fall out. This ensured that the rover could travel for miles without its wheels getting clogged or damaged. This handmade technology allowed astronauts to become true explorers, venturing far from their landing site to collect rocks and conduct experiments, expanding our knowledge of the moon in ways that would have been impossible on foot. After walking on the moon, the astronauts had to make the dangerous journey back to Earth. The command module, their small capsule, would re-enter Earth's atmosphere at an incredible speed of 25,000 miles per hour. This high-speed entry would generate immense heat, reaching temperatures of 5,000 degrees Fahrenheit, which is hotter than molten lava. To protect the astronauts and their capsule from being burned up, a special heat shield was needed. This shield was one of the most critical pieces of technology for the entire mission, as without it, a safe return would have been absolutely impossible. The lives of the crew depended entirely on its performance. The heat shield was not a simple metal plate. It was made of a special honeycomb structure filled with a unique resin. This technology was called an ablative heat shield. As the capsule blazed through the atmosphere, the resin in the shield would burn away, layer by layer. This burning process carried the intense heat away from the capsule, protecting the astronauts inside. Filling the honeycomb structure was a painstaking process. Workers used a special gun to inject the resin into each of the 370,000 cells of the honeycomb. Every single cell had to be filled perfectly to ensure there were no weak spots in the shield. Once the heat shield had done its job and slowed the capsule down, another piece of handmade technology was needed for the final part of the journey, the parachutes. To slow the command module from over 160 miles per hour to a gentle splashdown in the ocean, 3 enormous main parachutes were used. Each parachute was over 83 feet wide and was made from thousands of square feet of lightweight but incredibly strong fabric. These parachutes were so big, yet the material was so light that a square yard of it weighed only 1 ounce. The panels were sewn together by hand on regular Singer sewing machines. The construction of each parachute required 3.5 miles of thread and 2 million individual stitches. Every seam was carefully inspected on a light table to ensure there were no flaws. The folding of these parachutes was a job for only a few certified experts. In fact, only 3 people were licensed to pack the parachutes for all the Apollo missions. Their meticulous work ensured that the parachutes would open exactly as planned, bringing the astronauts home safely. From the fiery shield to the silken sails, these handmade technologies were the final guardians of the mission, completing the circle of a journey that started with a dream and ended with a safe return.